So I'll give you 5 minutes right now, talk over the first example, see if you can come up with a method. Radius of the circle is 4. That's all I'll give you. Find the area of the square. I told you, first of all, we got to go over this again because we're going to be using this phrase a lot today. Regular polygon. What do you know about a polygon if I tell you it's regular? Orion, what do you got for me? All sides are congruent. And all angles congruent. Yes. Okay, so if this is a 4-sided figure, all the sides and all the angles are congruent. I can rename it a square. Okay, area of a square. Area formula for a square then. Length times width, base times height, however you want to do it. All right, I saw a lot of people bust out the circle formula. This has nothing to do with the area of a circle. Okay, nothing to do with the area of the circle. It's just finding the area of a square, which means to me, you got to help me find one of the side lengths. All right, that's what I need. I need one of those side lengths because when I find it, it's going to be the length and the width, and I can multiply them together. A couple different ways we can go about it. It said the radius was 4. I saw a lot of people draw in a bunch of different radii, some which helped them, some which did not help them. You know, I saw this drawn in. That I don't know how you went from there. That really didn't help. What you could do, and again, this is just one way. I saw a lot of people draw in almost a partial diagonal there and say, okay, that's 4. All right, I saw some people draw in a whole diameter and say, all right, that's 8, and squares have right angles, so I'll do Pythagorean theorem. I also saw people just draw in maybe another radii here. Diagonals are perpendicular. They did Pythag with this right triangle instead. Fine. Fine. However you did it, one of the sides came out to be the square root of 32, or if you broke it down, what's that, 4 radical 2? Okay, so one of the sides was equal to 4 radical 2 or square root of 32. Excuse me, you could have kept it either way. So the area of this square, 4 radical 2 times 4 radical 2, should have ended up being 32 square centimeters. Okay. So why did I start you off like that today? Well, what if I threw a regular hexagon in there and said find the area now? Do you know the area formula for a hexagon? Me neither. What if I threw an octagon in there and said find the area of the octagon? Do you know the octagon formula? No, me neither. That's today's topic. All right. Any regular polygon, we're going to be able to find the area of, no matter how many sides the darn thing has. Okay. All right, we got a new vocab word, ladies and gentlemen, a new vocab word. Before I get to that vocab word, can anybody tell me what type of regular polygon this is? It is a hexagon, yes. And from the center, I've drawn in all 6 radii to each vertice. What do you know about all those radii? I know they're not in a circle, but now they're in a hexagon. What do you know about all those radii? They're all congruent, yes. All right, they are all congruent. And what do you know about the sides? They're all congruent because it's a regular polygon. So what do I know about all these triangles? All 6 triangles are, well, before I get to name what type of them, all 6 are what to each other? Congruent. Can you tell me something about these angles then? They're all congruent. Can you find one of those angles then? If they're all congruent and there's 6 of them, what's the angle measure of each of them? Should be 60 divided by 6, so each angle is 60 degrees. So take one of these triangles right now that I formed. What are the other 2 angles then? There's a 60 here. These 2 sides are congruent. What are the other 2 sides here? They are also congruent, so they're 60 and 60. So in this hexagon, what type of triangles were formed? Equilateral. All right. For the hexagon. Everyone all right how I got that initial 60? All 6 add up to 360 and they're all congruent. All right, you ready for our new vocabulary term? Anybody want to try it? Pronounce that bad boy. Apothem. All right, apothem. It is not opossum. All right, it is apothem. All right, I've also heard apothem as well. All right, but apothem is usually how you hear it. All right, here's what an apothem is if you read through it. Perpendicular distance from the center to one of the sides. So if I go start at the center and draw a perpendicular distance down to one of the sides, that is my apothem right there. All right, that is my apothem. Very, very powerful segment. Here's why. Anybody want to guess what the apothem does to that triangle? Okay, makes 2 right triangles. Yep. Good, good. Hence the right angle symbol. Yep. Hi, Maggie. Bisect the triangle? What do you... Okay, bisects that angle it's drawn from. Yes, it bisects this angle here. So these 2 angles will be congruent. Also, it does a little more bisecting than to the angle. It also bisects the side it's drawn to. Okay, so the apothem is pretty powerful. Bisects the angle and also the side. All right. Now, any thoughts on how right now, I know I don't have any numbers up there, but how I could find the area of that hexagon? How could I don't want formulas or anything. A way, a method, a plan to find the area of this hexagon. What did I just divide it up into? 6 what? Equal triangles. Do you know how to find the area of a triangle? So what I could do is take one of them and do 1/2 base, and now what's your height? The apothem now. I could do 1/2 base times height, find the area, and then do what with that one? Multiply it by 6. So you can find the area. Okay, you can find the area. You're not ready yet. I want to just find some of these angles now. I want to find some of these angles before we start finding actual areas. Okay, so these are all regular polygons. Can you help me find the numbered angles right now? Okay, can you help me find the numbered angles? They're all regular. You don't have to start in order. Remember what we just did with the hexagon. So I'm actually going to start with angle 4 right now. Angle 4. Can somebody find angle 4 for me right now? Oh, who's starting it off right today? 30. There we go. How'd you get it? Oh, okay. Yeah, she knew it was a square. Diagonals are perpendicular the other way. You could do 360 divided by 4 because we all know these angles are congruent. We found that out with the hexagon. All right, so good. That's a right angle. Can we go to angle 1 now? Somebody go to angle 1. 2, what do you got for angle 1? 45 degrees. Here's why. We just said, hey, what is this segment called again that I'm drawing in? That's my apothem. It also bisects the angle. The angle was 90. I bisected it, so now it's 45. Let's go to angle 3 now. Angle 3. 23. Angle 3. 90. Apothem is perpendicular to the side. And then finally, what about 2? 6. What about 2? 45. Oh, look what we're creating, huh? Our 45, 45, 90 triangles might have to do something with them. Let's go to the equilateral triangle now. Equilateral triangle. 5, 6, and 7. 5, 6, and 7. I'll go 7 first. Angle 7. 18, angle 7. Where'd you get 60? $120. Okay, how'd you get 120? Good. 360 divided by 3. Because we know all three of those angles when I draw on the radii are congruent. All right, let's go to angle 5 now. Angle 5, 24, angle 5. One job. And that's for me to know 24 is never existing. 21, angle 5. How'd you get it? The apothem bisects the angle. And then finally 6, angle 6. 11, what do you have? Angle 6? 30, 30, 60, 90 triangle. Okay, so we can find those angles. Teddy, we ready to tackle the whole area now? Let's find out. Okay, moving on. Whew. I do not want to give you the formula yet, because what class are we in? Okay, good. I haven't done that in a while. Felt good. All right. I want to try to do this without a formula. See if you can do it without a formula. Then I'll give you a formula, and then you guys can choose which way is best for you. So everyone, I got a regular pentagon. Let's see drawing skills here. How many sides? Oh boy. 5 sides. Each side, it says, is 7.2 feet. And it's got a 6.1 foot radius. Remember, radius is in a polygon acts like just the radius in a circle. But it's drawn from the center to a vertex now. Okay, help me find the area now. How many triangles could I draw in? I could do 5 triangles, right? I could draw in if I drew in all the radii. So the area we're going to say is going to be 5 times area formula for a triangle. 1/2 base times height. Okay. So let's draw in one of those triangles. Can you find the area of that triangle? Well, you already tell me what the base is going to be. What's the base of this triangle already going to be? 28. What's the base of this triangle? So 1/2 times 7.2. Now, when I draw in the height, that's, what do we call in the height here in this today? The apothem. How can I find the length of that apothem, which will be my height? Pythag. I only have 6.1. Yeah, what do you know the apothem does to the side? Bisects it, so 7.2 divided by 2. 3.6. Yes, so I can go h squared plus 3.6 squared equals 6.1 squared. Bless you. That's a long decimal, which we're not going to round. Or if you prefer, you can leave it as the square root of, what did it come out to be, 24.25? Yes, no? Okay. So you can leave that if you want, or you can write the long decimal down, but that's the height of that triangle. So times the square root of 24.25. Now I just got to multiply that number by 5 at the end, because there's going to be 5 of these triangles. I'll let you crunch away here. And nearest 10th when you're ready. Oh, 2 when you're ready, nearest 10th. 88.6 square feet. Got it. Everyone good there? Nice. Okay. Is there maybe a shorter way to do it sometimes? Yeah. All right, I'm going to give you the formula to find any area of any regular polygon, no matter how many of the sides. I need you guys to choose what you're comfortable with. You want to do triangles all the time and multiply by how many there are? That's fine. Or we could use the following formula for any regular polygon. Anyone. 1/2. It's a very easy one to remember. A. What do you think the A stands for? Apothem length. Apothem length. P. Perimeter of the polygon. So the apothem length and P is the perimeter of the polygon. 1/2 AP. Where's everybody going? Where's everybody going? Oh. Such a rough life I live, honors students. I debate whether or not to do this every year. I think you guys can handle it without some of you being offended and feelings hurt. Some of you might want to soak this opportunity in right now because this might be the only time these two letters are ever near you together. AP. Okay, so soak that in for some of you. All right. Yep. All right. AP. Soak that in. And if you don't get that one, it's never going to be associated anyway. So don't even worry about it. Okay, what was the apothem length we found? Square root of 24.25. And how do you find the perimeter of this polygon? 7.2 times 5, which ends up being 36. And if you guys do that real quick in your calculator, you'll find out that 88.6. So it's whatever you feel comfortable doing. Okay. I can tell you I won't say that to period 7. All right. Won't say that one to period 7. God forbid we joke around in that class. Or do any work. Moving on. No bias. No bias. Okay, the area of the equilateral triangle. Again, 1/2 AP, or do you want to cut it up into 3 smaller ones? Your call. Your call here. Do we have a preference in here? Or? Oh, your preference both ways. I love it. Okay, we'll go. We'll do it both ways then. What? 1/2 AP? Yeah, and then we're going to do 3 triangles. We're going to have a lot of fun, Maggie. Yep. We could start with 1/2 AP. Okay, so what is that? First of all, what's the 4 that's drawn in? 14. What's the 4 that's drawn in? That's the radius. Okay, that's the radius length. I need the perimeter and the apothem if I'm going to use 1/2 AP. So what I need to do is create one of those 3 triangles right now. So this other radii I just drew in also has a length of 4. And here we go. Now I need to find the apothem length and the side so I can find the perimeter. Okay, so I have a right angle there. Ooh, I'm giving you less than the last problem. How do I find that apothem length? Well, this is why I did all those angle measurements before. Ready? What's the full angle right here? Remember, it's a triangle. 120. What's the apothem do to it? Bisects it. So this angle will be not 120 anymore, but 60. So what type of triangle do I have? 30, 60. Yeah. You don't have to write it down. I'll just review with you quickly here. 30, 60, 90, x, x radical 3, and 2x. Where's the 4 across from? Here we go. 3. Where's the 4 across from? The 90. How do I get to the side across from 30 then? Divide by 2. So the apothem length is 2. So 1/2, 2. Now I got to find the perimeter. Let's keep going. What's across from the 60 then? 1. Great job. 14. What's across from the 60? 2 radical 3. But hey, is that the full side length? No. What's the apothem do? Bisects it, so I have another 2 radical 3 over here. What's one side of this triangle? What's the length of one side of this triangle? Woo! 15. One side. Stop being a superstar. One side. What are you doing in the calculator? What's one side length? What is going on back there? You don't need one! Orion, ready? 2 radical 3 and 2 radical 3. What is one full side length? Thank you. That's all I was asking. One side is 4 radical 3, and if I have 3 of them, full perimeter? 12 radical 3. Wow. Apologize to your classmates right now because everyone's IQ just went down a couple points. Apologize. And you just wasted somebody's oxygen, all right? All right, moving back. Simplest radical form. Radical 3 should be in our answer. 1/2 times 2 times 12. 12. 12 radical 3 be in the area. You know what, Maggie? Maybe I don't have the energy right now to do. Is everyone, if you wanted to break it up into 3 triangles, real quickly, it would be 1/2 times 2 times 4 radical 3, and then you multiply that by 3. Okay? Area of this triangle is 1/2 base 4 radical 2 times height of 2, and you go from there. All good? Wow. Oh, shoot. Good. 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 No, it's not. You had your moment in the sun this week. It's done. It's done. Not coming again. Okay. Area of the regular hexagon. 1/2 AP, or we'll break it up. Okay. I think we can fill in the perimeter first. Perimeter should be pretty easy to find here because I gave you one side was 3. $20 perimeter. 18, 3 times 6. Okay, now ready for the apothem now. Well, what's happening to AC here? It's getting bisected, so now I put the 1.5 on. I need more, though. I need more. Can you guys find the angles in that triangle? Okay, ready? Angle ABC, that full angle, ABC. Find the measure of ABC. What's that full angle measurement there? 17, what's that full angle measurement? 60, what's the apothem doing to it? So what's this top angle here? That's 30 now. And this bottom angle would be 60. Got it? All right, I got a couple more questions for you here. 12. Where's the 1.5 across from? The 30. So what would be across from the 60, the apothem? Yep, keep going. Everyone all right? 1.5 radical 3 is the apothem length. And I don't care what the hypotenuse is. It's not needed in this case. So I just plug in 1.5 radical 3. And now I can to the nearest tenth. When you're ready. 9 when you're ready. You're better than this. Thank you. Questions there? It's not. No. It's not. It's not. And then the square. This is where we started, and this is where we're going to end. Now you guys can do 1/2 AP. Hey, you can do 1/2 AP. Make 4 triangles. Or do Pythag and find a side and multiply it by itself. Look how many options you have right now. All right, this is why I wanted to end it like this. All right, you and your group, or you by yourself, go, explore it now. All right, explore it. You have many methods right now. You want to do it the same way you did as the beginning, fine. You want to explore 4 triangles, that's fine. You want to do 1/2 AP now, that's great.